You know, every session is being recorded and you can watch the lectures the next day. Then I should say, uh, let me see. Let me see what are we going to do. Okay, I'm just gonna, as I said, the lectures is being recorded. Right now, I'm just gonna take you with myself to a tour, which is gonna be just going to the Desmos. Okay. Everyone can see what I have on the Desmos?
Yes.
Yeah, fantastic.
Yes.
Thanks, Laura. Thanks, Anki. Guys, look at this one. This is, I have a function which is over here. A function which I have, this is going to be called the f of x. As you see, that's a single variable function because I have only one variable, which I made the transformations of it, and I represent that functions as this one which you see, 27x cubed plus 125 divided by 3x plus 5. The functions at the numerator is a polynomial of degree 3 with the leading coefficients, which is 27, and the functions which I have at the denominator is a polynomial of degree 1 or a linear functions which you have seen before with the leading coefficients of 3. Okay, and that's the function which I have. I have the ratio of two polynomials, then I have a rational expression. Okay, I'm going to plot this function to see how the plots should look like. Okay, I'm going to plot it, and I see a plot, which is plots in blue. It's denoted here. You see? I have a plot, and it looks like this. I can zoom it out, or I can zoom it in. But the thing is that we see that this plot somehow resembles to a quadratic functions which opens up, correct? However, guys, I am going to ask you, okay, I find from somewhere at the back of my mind another function, which this one also is going to be a single variate functions, which is going to be the f of x, which is going to be g of x. I call it g of x. The functions which I have here for the g of x, I'm going to represent it in a different way. Let me stop this function which I had before, and it's going to be 9x squared minus 15x plus 25. This is going to be this purple color function then. You see that? This is plotted. Now, guys, and also, I'm just going to click on the previous plot. Look at the plot which I plotted it right now as a single variable functions of the g of x. It's a polynomial of degree 2 with the leading coefficients of 9, correct?
Yes.
Awesome. And previous functions which I had, the f of x, was also the same thing. The previous functions which I had, it was what? It was a rational expression which was a division of a polynomial of degree 3 over the polynomial of degree 1. Look at that. When I plot both of them at the same time, you see, why do both of them look exactly the same function? Look at that. It's just, this is a Cartesian plane. I plot the first function, f of x, a rational expression, and I plot the g of x, the quadratic functions, and both of them, they are on top of each other. They're matching single point by point. Did you see that?
Yes.
Only one function. The second function comes on the very top of that function. Right? Then we see that for some functions like that, what's behind it? I'm just going to go back to, everyone is fine with the plots which I have done? No questions?
No question.
Then guys, you will see that sometimes, thanks Laura, you will see that if I give you this function, which this function is a rational expression, and you are going to plot it, you see, oh my God, this function is not easy to plot it if you do not have, let's say, a graphic calculators, a graphical softwares which plots that function. You will see that this function is is not easy to plot it. But a functions like that, which is I should say a quadratic functions, with the leading coefficients of the 9, it seems significantly much easier because you see that it's the leading coefficients is positive. It's just going to point upwards. It's going to open upwards. You can find the critical point here by the method that you have learned. Then, okay, I'm just going to go ahead and plot it. And now, the thing that we just want to start on, that's going to be a good reason to see what is behind these functions that we can just simplify to these functions. How can I get, if I have f of x like that, how can I simplify to the g of x that at least the plotting should be much easier? Okay, that's gonna be the purpose of the lesson that we are just gonna run into. Okay, any questions? Everyone is fine?
Yes.
Okay, thanks Laura. Now we just go to the next one. Oh, I had the coffee, now it's getting too cold. Okay, let's go back there and let me start. Okay, the first function which I had, what was that? The first function which I had, it was called f of x equal to, it was a rational expressions which I had, and the rational expressions which I had, it was denoted like this. It was the thing which I had was 27 x to the power 3 plus 125 divided by 3x plus 5. Correct? That's what I had.
Yes.
And now, the first thing that you can think to yourself before, if I ask you guys to plot this function, if you have a functions like that, even I do not ask you to plot it. I do not say anything to you. Somebody pushes this one. Somebody pushes this plot to you, and you will see that, okay, I have a functions like this. You do not even want to plot it. But the only thing which attracts your attention is the denominator which you have there, which is 3x plus 5. And I do not say anything to you. I draw these functions at your table, and at the first look, the thing which notices your attention is the denominator. Why? Because you say that, what if 3x plus 5 becomes 0? If it becomes 0, I'm screwed. Why? Because I have a rational expression. Because in that sense, I have a rational expression like a over b, which in that I have the b is going to 0, then the whole expression is going to collapse. And that's the problem. Then that's the basic thing that, I do not ask you to do anything. That's the first thing that you just came into your mind to do with it. Then you say that I know that x can be anything except the fact that x should not be equal to minus 5 divided by 3. Then as a result, you say that, okay, I'm not going to do anything with functions, but I know the domain of the functions is going to be x. All of them is going to be the real numbers, not any imaginary or complex numbers is going to get involved. However, x should not be equal to minus 3 over 5. Sorry, minus 5 over 3. Okay? That's the first thing that you do. Okay. That's the first thing which comes to your mind. That's a very reasonable thing to do. I'm just going to go back to the domain of the functions which I created it here in a couple of minutes. Okay, the first thing is that you see two functions are being divided to each other. The second question which it may come to your mind after, guys, listen, still I haven't asked you to do anything with this function. Still, I haven't asked you to do anything with this function. The first thing which comes to your mind on instinct is that to find a domain, to find the points which the function is going to collapse. The second thing which it comes to your mind is that to ask yourself this question, if this function, if the denominator is a complete factor of the numerator. Because if that's going to happen, I can write the function just in simple terms. In order to answer that question, we have one very simple strategy to follow. We can come here and say, okay, in order to ask that question, I'm just going to write, I'm going to divide 27x cubed plus 125, which is going to be divided by the denominator, which acts as what? Which acts as the divisor of my function, which is going to be 3x plus 5. Correct?
Yes.
Thanks, Laura. And now look at this one. What I want to do this one here, you learn based on the things that we have learned since 2 days ago. We just come to search for the first items. But before that, we make sure that we check the first thing, that we make sure that our, I should say, terms are ordered in a descending order, which is correct in this stage. Then I see that in order to kill the first term, I notice that if I multiply the first term by 9x squared, I'm just going to kill the first term. Why? Because the first term, when you do that, you just multiply this to the first term, then you're going to get, let's say, 27 x cubed, x squared times x becomes x cubed, plus 9 times 5 becomes 1, because 45 x squared, then that's going to be a safe spot right now to close, I should say, the step. Now, on the next step, I'm just going to see what is left for me. The thing which is left for me, these terms are going to be gone. Then I have what happened? Then I have minus 45 x squared plus 125. These methods, we covered that since 2 days ago, and I hope that you should be fine with it now. In order to the first term, to kill the first term, you notice that if you multiply that by minus 15 times x, you can kill the first term here, because minus 15 times plus 3 at the divisor, it produces, I should say, minus 45, the exact leading coefficients, and x multiplied to x, it becomes x squared. And also I have this term, minus 15 x times 5 becomes how much? Minus 75 times x. This one is going to be a safe spot to close, I should say, the step. I'm just going to simplify that further. These terms are going to be gone. And this one is going to be gone. What term is going to be left here? This term is going to be gone. Then I have plus 75x plus 125. Because I know that if I close this step, I put the minus sign, these two terms are going to be vanished, and I have plus 75x, which I bring it here, plus 75x, and I have 125 here, which is left here. And I know I take a look at the next term, which I have here, 75x, and I take a look here, I notice that simply the power is going to be 1 for x, and the power is 1. It means that still I can continue with the dividing process. Then what I'm going to do here is that I multiply this to what? In order to get rid of 75x. I know that if I multiply that only to 25, I get 25 multiplied to 3x. It becomes 75x. 25 times 5 becomes exact 125. Correct?
Yes.
Fantastic. Then what's going to happen if I close this step? I notice that, okay, I'm just going to subtract this term from the previous remainder, that I get the 0 remainder. Is it correct, guys? Everyone is following me so far?
Yes.
Yes.
Thank you. I was sipping on my coffee. Now, what's going to happen now? You see that when we just reach to a remainder, which is 0, we can make an inference that the thing that we have over here we can write it here. We know that 3x plus 5 now is a complete factor of our numerator. Then I can simply write here 9x squared minus 15x plus 25. Which you see that, okay, then you should be surprised to see that this is going to be exactly the second plot that we had it here, and I called that g of x. Do you remember that on the Desmos? Guys, do you remember these functions on the Desmos
Yes.
that we plotted?
Plot.
Say what?
Oh, what is plotting? Sorry, what do you say?
Yeah, say, sure. Look at that. Please look at this function, 9x squared minus 15x plus 25, which is the result of dividing this cubic expression into this linear expression. That's right. And we get the result here. I'm going to take this result, bring it here. Right?
Yes.
That's right. And look at the Desmos which I had. I'm just going to share my screen again, go back to the Desmos. And look at the Desmos here. Look at the functions g. This is f of x that we had this on our whiteboard. You see that? And now we have this one g of x. The g of x, essentially, that's the result of the division of the numerator with respect to the denominator of my f of x. Correct?
Yes.
Good. Then you see that these ones produces the same plot. However, if I go back to the, I should say, the whiteboard which I have, however, the thing that we see here, which is going to be 3x plus 5, the thing is that with this function, if you do not want to see the plot, you initially say that, okay, x should not be equal to minus 5 divided by 3, which makes this point a kind of, they call that a singular point. Have you heard that before?
No.
They call that a singular point. But when you plot the functions, you will not even see that function is defined on the graph. That's why you say that this point, which seems to be an odd point in the domain of the function. Look, let's go back again to the plot. Look, remember the point which it was minus 5 divided by 3. Look at this, minus 5 divided by 3. It means that the function is going to be, you see, everything, everywhere the function is defined now. You see that on the x-axis when it gets negative numbers? You see here, you do not have the trace of that thing. And you see that everywhere the function now is defined, and we do not have that singularity about that point. You see that? There is no
Yes.
point of minus 5 over 3, which we had to just put this extracted from our functions. Everywhere the plot is defined. Look at that. I'm just going to also plot this one. X equals to minus 5 divided by 3. Okay, there we are. Guys, please listen to this part because that's a very tricky part of the lessons that we have today.
Okay.
I'm going to zoom again. Okay, I think we should be fine here if I zoom it here. Okay, yes. Okay, guys, look at here. Please, everyone, listen to this very carefully before we move on to the next new lesson then. This is very crucial, very crucial. Everyone, please say their name. I want to make sure that everyone is listening.
Laura is here.
Thanks, Laura.
Here.
Sylvia
Anki
is
is
here.
here.
Thanks, Sylvia. Thanks, Anki. How about Jasper? Okay. Guys, look at this one. It is very crucial. Please listen very carefully. At the initial functions which I had, look at the functions at the very top, which is f of x. It's a rational expressions of the cubic functions over a linear functions. In these functions that we had, the most logical first step that we have to take was to see what is the point that the function is not defined. That's what we call that the point of singularity. What points are not defined in the functions? They are the points that they took the denominator of the f of x going to 0, which it means that 3x plus 5 becomes suddenly 0. And that's the reason that it collapses f of x. And that's why we have to identify that point and remove it from this function. And that point is going to be very easy to find it because you say 3x plus 5 equals to 0, then x has to be minus 5 divided by 3, that it causes a collapse of the function. What is that point? You remove it from the domain of the function. It means that this function then is defined everywhere except at the point which is going to be minus 5 divided by 3. But look at this one. This is our prediction before we plot it. But guys, look at this. And now it's gonna be the magic. The magic is happening right now. Please listen very carefully. But you plot the function, you see that the point, which is gonna be x equal to minus 5 divided by 3, which is approximated to minus 1.66666 goes all the way to the 7. It's the same point that initially we identified it and we diagnosed it that it should not be part of the domain of the function. Then when we expect that when we plot the function, this point should not be part of the function. But look at this one here. I plotted another functions in black, which is essentially the same point. You see that they are just at this point minus 1.67 and the y coordinates is 75. At one point you see the black line, which is this is the plot of x equal to minus 5 divided by 3, which is our singular point, and the f of x, which is this blue line. I hope that you see that. Everyone sees these two plots?
Yes.
Awesome. Then you see that although we expected that point minus 5 divided by 3 on the x should not be a part of the function, you can clearly see that this point intersects also with this function and it's defined on the function. Then what is wrong now? Now on the plot, this point belongs to the f of x, but analytically you understood that this point should be excluded from the function because it causes the functions to collapse. Then what happened there? I just want everyone to spend 30 seconds to think what happened. What is the reason why this contradiction happened? Did you get what's the question, guys? Yes?
Yes.
Do you find any answer for it?
No.
How about Laura? It was you?
No.
How about Anki, Jasper, and also Celia?
No.
Do you have any answers for that mysterious thing which happened, the magical thing which happened? Look at this, what happened. We say that when we make a division, when we look at the f of x, of course, the point of x equal to minus 5 divided by 3, which is the 0 point or the root of the denominator, is just, I should say, a singular point. This is completely correct. However, when we make our transition from f of x to go to the g of x, by doing the division, essentially we are removing that singularity from the function. It means like what? It means like that, for example, f of x, imagine that the point of x equal to minus 5 divided by 3 is a tumor in the brain of that function. It means that the function f of x is sick and it has a cancer tumor in his brain, and that is minus 5 over 3. You take this function to Anki, who is a surgeon now, and Anki removes that tumor from the brain of that patient. And now we reach to the function which is g of x, and the function's g of x is now cured. It has been treated, and we do not have that sickness, that tumor in her brain. and the functions is acting normally. And that is the reason that although f of x has a singularity at point minus 5 over 3, but that singularity, we call that it is removable. It means that you can take this out. You can put your hand, put this into the function, take that, I should say, that point minus 5 over 3 as a singular point, and the functions behaves naturally and normally. Huh? And that's why we call that point minus 5 over 3 a removable singularity. Guys, this lesson is extremely important in the concepts of the functions which you have had. How a singular point of a function is removed and makes the functions continuous. Everyone got that?
Yes.
Any questions?
Yes. No, no question.
Awesome. How about Sylvia and Laura? No questions?
No.
Okay, fantastic. This part was extremely important, and I hope that you also shared that importance, that vision with me, because it was very important. And I got get back my plot to its normal scale. You see that the plot is this. Okay. Now, I'm gonna go back to, I should say, my whiteboard. Okay. Now we just start the new lesson. The second new lesson before we just go for the break to see what's gonna happen then. Okay, now, guys, still, I'm just gonna use this thing which I used here, this function. I'm gonna use this function. However, I wish if I could have saved. Oh no, it seems that I cannot copy paste from this menu. No problem. Okay, now I'm just gonna go back again to rewrite the function because now I'm just gonna approach the second method. I know that f of x, it is this function of 27 x cubed plus 125 divided by 3x plus 5. Okay, now I'm going to just approach it based on the second method. Still I know that the point minus 5 divided by 3 is a singular point, but I'm not going to get into that point. I'm just going to show you what I'm going to do as a new lesson. Look at this one. I'm just going to rewrite this term. Look at this. The new, guys, please listen exactly to what I'm going to say. Look at the numerator which I have. Okay, that's going to be my numerator. I see at the numerator, I have two terms. Please listen exactly to what I'm saying, step by step. At the numerator, I have two terms. The first term is going to be this, and the second term is going to be this. The third thing is that I can see the denominator, the numerator which I have, it has a variable x which has power 3. That's the third thing. And the fourth thing which I notice particularly here, I see that the sign between these two terms is a plus sign. Okay, I check these two things and I smell something. When you see these kind of stuff, it's a kind of a diagnosis for you. You say, okay, wait a minute. The numerator has two terms. One of the terms, the variable, is to the power of 3. And the next thing is that they are summed together. When you smell these things, you can look at that, it's going to be you. And you start to think of a thing. You smell these things. For example, it's going to be your nose. You smell that thing and you start to think of, you have a cloud, then you start to think of something. And that thing is going to be this. It's going to be that thing. You say that. When I have two terms, it's going to be, for example, the first term, a to the power 3. Let me write this thing right now here. You have, for example, you have the first term as, for example, you have a term which is the power 3. For example, the one which we had, which is summed with another term which we can make, which is power 3, or we force it to be of power 3. We can think of this a to the power 3 plus b to the power 3 becomes a plus b times this term, a to the power 2. Guys, you see the screen now?
Yes.
Yeah, you see that?
Yes.
Okay. It becomes minus ab plus b squared. When you smell something like that over there, you can think of this. I put it as a cloud that you are thinking of it. Okay, I can think of this to see that if I can just write the thing which I have at the numerator to look like this. How to do that? I have 27 x cubed plus 125, which is at the numerator of my expression. I can see the first term which I have. Look at the first term. And also look at the second term. It seems that I can manipulate somehow to write it like that. I can say, I can write it like, for example, for 27x cubed, I can write it as, let's say, 3x, which all of it goes to the power 3. I can make sure that it's going to be right. I know that 3 to the power 3 becomes 3 times 3 becomes 9. 9 times 3 becomes 27. Then I have x cubed plus I have 125, the second term. For the second term, how can I write it? I can write it as, can I write it as 5 to the power 3? Then wait a minute, it can be possibly right. Then I have 5 to the 5 becomes 25, and 25 times 5 becomes, 125. Correct? Then as a result, the thing which I can write it like that. So far, so good, everyone?
Yes.
And now look at this. I can come here to compare this term with this. I say I have the first term. It's like the a, which is to the power 3. And I have the second term, which is b, like it's going to the power 3. You see that? Then it's going to be exactly the thing which I had. Then what do I do here right now? I come here, okay, I say I'm just going to use this formula, write it in that way. I say that, okay, my a plus b, my a is 3x, my b is 5. it becomes 3x plus 5, multiplied to a squared. My a is 3x, then a squared becomes 9x squared, minus a times b. A is 3x, b is 5, multiplied to that minus becomes minus 15x plus b squared. My b is 5, b squared is becomes how much? Becomes 25, correct?
Yes.
Fantastic. That's the thing which I can think of it as a sum of cube. They call that sum of cube. If I know this method here right now, then I can come here, go back again to the previous line which I had, and I write it like that. I say, okay, now the thing which I want to do is this. I'm just going to write this expression as this one. Write 3x plus 5 times 9x squared minus 15x plus 25, which is essentially the one which I have drawn it here based on this identity. And what do I have at the denominator? I have 3x plus 5, which is this one. I take it here. And now take a look. I see these two terms are the same. I can factor them out to end up with this final result, that this one is going to be what? 9x squared minus 15x plus 25. And that's essentially the same answer that we got it when we tried to divide these terms to each other. You see this result? It's
Yes.
exactly the same as you will see with this one, which we learned it. If I use this, I should say this this identity. This identity is called sum of the cubes. This is called sum of the cubes. Sum of the cubes. That's the name of this identity. Does it make sense to everyone now?
Yes.
Awesome. Then remember this identity. We are just going to use that a lot in the advanced functions 12. It becomes a kind of a lifesaver. Okay, now we need a couple of more minutes, then we just go to do some exercises. Okay, now. Okay, now let's go to this next topic then. Okay, look at this one here now. I'm just going to give you, it's going to be the last example, then we just take our last break, then we just come back, we continue with some exercises, a part of the lab, and also Laura's, I should say, presentation. Look at this. Now I'm just going to talk about another function. That function, I'm just going to call that h of x, which is going to be, let's say, 7x to the power 4 minus 448. Minus 448 x. I think with the x here should be nice. Look at this function. With this function, I'm not going to go to so much details like the one which we did on the previous example, but I just want to jump into the identity that we are just going to try to find for this one. Okay. Look at this one, guys. For this one, for the h of x, the thing that we can do is that, is it possible if I look at the function h of x, which is a single variable function expressed in terms of the x, I see that I have two, because normally what we are interested in functions when we see the polynomials, we try to make some kind of a appropriate factorization. Look at that. I have the x, which it can be, it's the singular terms within these two terms. Then I can say write up h of x like that. Then I can write h of x. I can factor out, I should say x. Then I'm just going to write it in that way to say that it's going to be what? It's going to be 7x cubed minus 4, 4, 8. Okay, I just factorized 1x, and the function is going to be expressed like that. Okay. The next thing which I see somehow a kind of a similarity between the previous example and this one. Again, I see that I have two terms in this expression, which one of the terms is with the power of what? Which one of the terms has the power of 3. That's the thing which it makes me suspicious. If I can use the identities, which they are called the cubes identity, the cubes family identity. Why? Because I see a term inside the parentheses, I mean. When we factorize, when we have not yet factorized x, it's too far off from our vision. But when we factor x from this, you see that it's getting so close, because we have x cubed here, and we have two expressions which they are subtracted from each other. Then maybe I can just lead to a cube function's identity. But not necessarily, because I see that one here, if x to the power 3 becomes x cubed, then how can I talk about the 7? Can 7 still be, I should say, be written as something like that? That I do not know what is that number. It goes to the power 3, then it takes me to number 7. And I do not know, I put the question mark inside this. Can you find any number like that, guys?
Yes.
What is that? What is that number to the power 3 becomes 7?
Um.
Maybe you're saying that, for example, if I write, for example, any number, the question mark can be written as root of 7, but it's going to be 3 here. Maybe that's what you mean, huh?
Yes.
Then when you take question mark inside this squared, you see that? If power 3 comes here, then we have 7. It's one way to think of it, Laura, Anki, Sylvia, and Jasper. But the other way, it can be somehow like that. I say that I can go ahead with this method, or I ask myself another question here. And the question is going to be this. Can I also factor out 7 to get the coefficients of the x cubed equal to 1? Because it's sometimes always easier when we have the cubic family to have the coefficients of the x to the power 3 become 7. If I'm just going to factor out 7, it means that I have to write 7, and I had x from the previous factorization, but the plan is going to be very easy now. I get x to the power 3 because 7x is factored now. But all depends if this number, which is 448, can be factorized by 7. I mean that if I have 448 divided by 7, it comes to a remainder of 0. Then it means that 7 is a factor of 448. Then I can just write whatever comes here. That's right. Then okay, let's go on and I see if I can do that. If I do this, it comes 6 times 4, it becomes 42. Then I have what? 8 as a remainder. Then I have what? Then I have 4 times 7 becomes 28, and the remainder becomes 0. Correct? Then it means what? Then it means that I can safely come here and also write this one like that. Write minus 64. Where did I get 64? 64 is essentially this. Because 7 is a factor of 448. Now, okay, I'm just going to continue go to the next line. I have still 7, which is factored recently. I have still x. I have, I should say, my x cube, which is perfect. That's what I need. But look at this one. I have 64. Can I work with the numbers in my mind? I use my brain to work with the numbers and see if there is any number. I mean this. If there is any number that when it comes to the power 3 becomes 64. Is there any number if when it comes to the power 3 it reaches to 64?
Yes.
What is that number?
4.
That's so true. Thanks. That question number is going to be 4. It means that then I can simply come here, write 4 to the power 3. And I think I should be fine at this stage because I do not need to go further because I have the full expression now, which 7 times x is factored outside. It's going to be my 7. It's going to be my number, which is going to be the x. And I have inside the parentheses something that everything is cubed. Look at this one. I have the first term to the power 3, and I have the second term to the power 3. It makes life to be perfect for me. Life now is incredible for me. But why? Because I know the second member of the cubic family, I call this a brother and sister of the cubic family, which they look like this. We say that if a to the power 3 minus b to the power 3 we have 2 parentheses to make this cubic. We call that the cubic difference. When we have this, we have 2 parentheses to take. The first one is going to be the 1a minus b. Look at this. A cube minus b cube. The closest parenthesis is impacted by the sign of these ones. If this is minus, the closest parenthesis, the smaller one gets the minus. Then I have a squared. Because this is minus, now it becomes plus ab plus b squared. And I should say I'm gonna love this so much. This is the one which this is the one which I love it very much. Okay, if that's the case, I'm just going to use this and come here and to, I should say, simplify the things which I have. Look at this. These terms are essentially like these ones. I have x cubed minus 4 cubed. I can follow the roots here, and I say it now becomes 2 parentheses, which I have to write. On the first parenthesis, which I have written here, I have a minus b, which means that it becomes x minus 4. It multiplies to a squared. My a is x, becomes x squared plus ab, which means that it has to be plus 4 times x plus b squared. My b was 4, it becomes 16. Then it means that, oh my God, my life is now very easy, because previously I had an expression which I couldn't work through this, and that's why I used first factorization of 7x in 2 different stages. Then I reduced my expression. That's with the, I call that the cubic family. The previous one which you saw here, let me also put the heart next to that, because that's the one which we love it. This is going to be the sum of the cubes. This is called the difference of the cubes, and we call that the cube family. I always look at this one as a brother of the family, and this one as a sister in the family, which you see that it just simplifies our expression in a very neat and easy way then. Okay, guys, any questions?
No.
Everyone is fine?
Yes.
Sylvia is fine. How about Laura?
Yes, I'm fine.
Awesome. How about Anki?
Okay, I'm fine.
Awesome. How about Jasper? Okay. Okay, guys. Now, if you have no questions yet, I just wanted to say that it's almost towards the second and the final break time. Then the thing which we do is that I think the best thing to do is that we just go for our break, take 15 minutes break. When we come back, we just go to the textbook to do some exercises, and if Laura is ready, she can start the presentation. Okay?
Okay.
Awesome. The time is now 10:48, and now imagine that it's come back by 11:03. Is it good?
Yes.
Awesome.
Yes.
Come back, please, by, I think 11:03 is gonna be fine then. No, it's 10:49. Come back by 11:05. Okay. I see you guys back in 11:05. We continue then. Okay.
Okay.
Awesome. See you later and enjoy your break then.